We are interns at Bennett University undergoing summer internship slot 3 under Leadingindia.ai, and we were provided with a live Kegel competition on detection of pneumothorax, and throughout the project we were mentored by Mr. Malbugund, Mr. Tejalal and Ms. Divya.
Our project deals with pneumothorax segmentation. Pneumothorax is an abnormal collection of air in between lungs and chest walls. This is caused due to chest injuries. Such regions are diagnosed by studying the X-rays of affected regions. However, manual segmentation is a tedious task, so we propose a model for automatic segmentation of pneumothorax in chest X-rays. Now we will see about the dataset. The dataset consists of two parts. One is the test set and another is the train set. The train set consists of 10,700 images, whereas the test set consists of around 1,300 images. Annotations to specify the disease-affected area are given as run-length encoded masks. These are further converted to PNG images for further experiments. Images with disease are given encoded binary masks, and those without are given a mask value of -1.
After going through the dataset, we now come to the part of models. Going through the models, we have two different approaches. One using pre-trained model and other using the classifier and working with the other models. We are using the models like ResNet, mask RCNN and UNIT. Since our models were required to be trained again on dataset because fine-tuning was not an option for us. So going through the models, we got to know certain advantages. UNIT model was doing downsampling and upsampling for us in the architecture itself. The ResNet model was learning from the resolution of the images, going through the layers, and the final model mask RCNN was a combination of RCNN and FCNN. It was just giving a product output in different two sections. One was the localized image and the second one was the mask in the different layer.
We have gone through a dataset and our models. As mentioned, we are using UNIT and mask RCN. We implemented our model first using UNIT, which of course uses Adam as its optimizer and loss function as binary cross entropy. And still we experimented with the different learning rates and different optimizer to see how it differs with the test accuracy. For first we used Adam as the optimizer and learning rate with 10⁻⁻10, and we got a test accuracy around 78.86%. The code was set to run for 200 epochs, but we have designed a code in such a way that once it gets stabilizes, the loss gets stabilizes, it stops, such that it stopped around 21st epoch. And as mentioned, it got 78.86 as the test accuracy. And to try out different optimizers, for example, we tried with SGD with a learning rate of 10⁻⁻5, and the accuracy was pretty low. It was 3%. To be frank, it was 3.35%. So we stopped with SGD and again ran with different hyperparameters and all, and we were stuck with 78.86 for a pretty long time. We went through different pre-trained models and model architecture and finally came to a conclusion to use mask RCNN, which supports both ResNet 50 and ResNet 101 as its backbone, and our model uses ResNet 50 as the backbone. And talking about the input data set, it had light to medium augmentation such as geometric transformation, blur and sharpness, brightness and contrast normalization. And about the training part, it's scheduled to run in 3 sessions, and for each session with different number of epochs and different number of learning rates. And the first section has 1 epoch and its learning rate of 12 × 10⁻⁻² with none of the image augmentation. And the second session is set to run for 13 epochs and a learning rate of 6 × 10⁻⁴ with image augmentation. And the third part is set to run for 4 epochs and a learning rate of 3 × 10⁻⁻⁴, and with a light to medium augmentation, same as the second. And the steps per epoch were 350 and validation steps were 120. And with this model, we were able to achieve a test accuracy of 79.29%. And we did experiment with different number of learning rates, number of epochs, and 79.29 was the best we could achieve with this model.
Pneumothorax in lungs is detected in test images using the mask RCNN model implemented. It was possible to yield an accuracy of 79.29%. Augmentation used in the model is used to increase the accuracy and decrease the loss. The model has been run for more epochs to increase the accuracy. Talking about future scope, we aim to implement new models available in the market such as SVM with ResNet 50 and thereby increase the accuracy. A real-time application of our algorithm deployed on Raspberry Pi is also under consideration.